So, slight review here. Lewis dot structure for hydrogen. What does the Lewis dot structure show? Valence electrons. So for hydrogen, we know it's in group 1. How many valence electrons does hydrogen have? 1. So hydrogen symbol is H. I would draw it with 1 valence electron, or 1 dot. Now, hydrogen's in group 1, but group 1 we know to be a group called the alkali metals. Hydrogen's technically not considered a metal. Why is it included in group 1 though? What do you mean 1 electron? Alright, so we know hydrogen has 1 valence electron, and everything in group 1 also has 1 valence electron. What about group 2? How many valence electrons? Okay, skip the transition metals because they're weird. Group 13 has how many valence electrons? 3. Group 14 has how many valence electrons? 4. Nitrogen's group, group 15, has how many valence electrons?
5.
Oxygen's group?
6.
The halogens, group 17, has?
7.
And the noble gases have?
8.
So we have a general trend on the periodic table that we can look at for how many valence electrons are in particular elements. So, in this case, yes, hydrogen's not a metal, but we can put it in the same group as the alkali metals because all of them have 1 valence electron. So, why is it in that group? 1 valence electron, just like the rest of the group. Hey, what's the Bohr model for hydrogen look like? If it's the most common isotope, hydrogen 1, how many protons do I have? 1 proton. How many neutrons? 0 neutrons if it's hydrogen 1. And how many electrons? 1 valence electron. So just to prove my point for number 2, lithium has how many valence electrons? 1. So if we look at group 1 with lithium, or we look at the first energy level, we have 2 electrons. Second energy level, we have 1 electron. There's your valence electron. For sodium, same thing. I have 2 in the first, 8 in the second, and 1 in the third. For potassium, same thing. I have 2 electrons in the first, 8 in the second, 8 in the third, and 1 in the fourth. Again, that outermost electron, that valence shell, each of those in group 1, each of those metals plus hydrogen, all have 1 valence electron. Did anybody define the term quantized? There you go. Discrete values. Discrete values. And let me do a little analogy here that will help you understand this term discrete values. Has anybody walked up these before? Right? Has everybody walked up these before? Now, you guys step from one stair to the next, to the next, to the next, to the next. Everybody agree? What happens when you're running upstairs and you try to step right here? Yeah, you fall and bust your nose. So the idea here is you have discrete values for each of your stairs. You can't go anywhere in between the stairs or you're just going to fall flat on your face. Has anybody ever climbed one of these before? So again, you have different rungs on the ladder. What happens when you try to put your foot right there? Yeah, nothing good. You have discrete values you have to step on the ladder in order to use the ladder correctly. Now, when we talk about electrons, where do I place my electrons around the atom? On the energy levels, on the rings. So, I have 2 electrons in my first energy level, 8 in my second, 8 in my third, 1 in my fourth. Are any electrons located between the energy levels? No. So these electrons are filling in, and they have discrete energy levels. These electrons are quantized. So the way we fill in electrons, we fill them in a quantized manner around the nucleus. Now, what's the opposite of quantized? Inquantized, dequantized, no. So, the opposite of quantized is a term called continuous. Is everybody familiar with number lines? So here's 1, here's 2. How many points can you draw in between 1 and 2? An infinite amount. That implies continuous. That's the term continuous right there. If I ask you to draw or touch every point in between 1 and 2, you can literally touch an infinite amount of points. What's another example of continuous? Ooh, I think I have it in here. Oh, come on, work. Oh, what is this? I was trying to do a rainbow. But it doesn't really give you a rainbow. All right, there you go. All right, so, hey, stay with me here. When you look at the difference between this color and this color, green and blue, how many colors are in between that green and blue? It's an infinite amount of shades of green and blue combined. If you look at a rainbow, how many colors are in between the start and the end of the rainbow? An infinite amount of shades of color. Because every point you make is going to be a slightly different shade. Okay? So, that covers, that covers a summary of how electrons fill in a quantized manner around your nucleus.